Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about parallelogram proofs. We're going to do 3 different examples, different proofs where we're either trying to prove something is a parallelogram or we're told it's a parallelogram and we're trying to prove something else. There are 3 videos I'm going to recommend you watching before you watch this one. Those videos are going to be, and I'll link them to this video. My video on triangle congruency, my video on intro to proofs, and my video on parallelogram properties. If you get stuck at any point, you might want to refer back to one of those videos where I talk about some of these things in much greater detail. When we are approaching this problems that we're starting with, so it says our given statement is that cats is a parallelogram. Okay, so we've got this shape here, C-A-T-S, cats, and they're telling us right up front, hey, this is a parallelogram. And they're wanting us to prove that triangle CAT, so this triangle right here, so that's kind of like if you thought of it like maybe the top triangle in this picture, is congruent to triangle TSC, so this bottom triangle. So we need to prove that the top triangle is congruent to the bottom triangle, knowing that this is a parallelogram. And I get it, that the struggle with proofs is you want to just say, well, it is. If CATS is a parallelogram, then yes, those 2 triangles will be congruent. We just know that. But that's the tricky thing about proofs is you have to prove it, right? So step by step, line by line, why is it true? So proofs can be tricky for that reason, but we're going to take this line by line and we'll get through it together. We always start with what we know. Okay, what have they given us? So our first statement is going to be exactly what they told us. Cats, or CATS, is a parallelogram. And how do we know this? Well, we know it. Our reason is because it was given to us. So then we have to think, okay, what's going to be the best way to go about proving that these 2 triangles are congruent? I always go for side, side, side. So remember in our triangle congruency, we talked about the different ways to prove triangles are congruent. To me, side, side, side is always the easiest if you can go that direction. In this first example, that's what I'm going to do. I'm going to do just the easiest thing, which I'm going to shoot for a proving that all the sides have a congruent partner. Let's think about if cats is a parallelogram, then going back to those parallelogram properties, I know that this side would have to be congruent to this side, right? That's one of the basic principles of a parallelogram. So I know that line CA is congruent to line TS, right? And notice I've now marked them. I always think it's a good idea that as you do these proofs, you mark the picture as you go. That's just my personal preference, and that's what I'm going to show. Like, what do I know about this that is true? And actually mark it on the picture so you can kind of follow along. And how do I know that CA is congruent to TS? Well, it goes back to that rule of parallelograms. So I always just note that as opposite sides of a parallelogram are congruent. And some teachers may be totally okay with you kind of shorthanding a bit. Like I notice I use the symbol for congruent instead of actually writing out congruent. Different teachers are going to have different preferences, so just make sure you're paying attention to what your teacher requires. But for this video, I'm just going to use some shorthand. So let's think of what else we could say. So we said CA is congruent to TS. We could also say that CS is congruent to TA, right? Because if this is a parallelogram, then our opposite sides have to be congruent. So let's write that one down. So for our statement number 3, we know that line CS is congruent to line TA. And how do we know that? Well, for the same reason as number 2. We know that opposite sides of a parallelogram are congruent. So I'm going to rewrite that again. Okay, so what else do we know? So again, think about what we're going for. I said right at the beginning I wanted to try to prove side, side, side. So far I've got this side is congruent to this side, and this side is congruent to this side. But let me now look at that interior, right? This, if I were to take those two triangles and separate them, this middle line right here, this diagonal, is actually two separate lines, right? They're just overlaying each other if I were to separate these triangles. So we can say that line CT, so from here to here, is congruent to, and you could either say CT again, or I like to change it up. I like to then go TC, right? That's just personal preference. So that this line is congruent to this line. And how do we know that? Well, that's a very special reason that we call the reflexive property. So in the reflexive property, what we're saying is something is equal to itself. And it's a very common property that we use in proofs. So now, at this point, we can say that triangle CAT is congruent to triangle TSC, that these two triangles are congruent to each other based on the triangle congruency of side, 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 right? All of the sides are congruent to each other, side, side, side. So we can now say our proving statement. So triangle CAT is congruent to triangle TSC, and we know this through the triangle congruency rule of side, side, side. And some of your teachers may want you to write out side, side, side. I just like to use SSS. So in this example, they also give us a statement, our given is that frog, F-R-O-G, is a parallelogram. So they're telling us right up front, hey, this shape is a parallelogram, which means there's a lot of different things we could prove about it knowing that it is a parallelogram. But they specifically want us to prove that triangle FSG, so FSG, so this like top triangle right here, that it is congruent to triangle OSR. So OSR. So that's this bottom triangle. So we're trying to prove the top triangle is congruent to the bottom triangle. And this can get tricky because there's 4 different triangles that we're looking at in this shape, right? There's this one, this one, this one, and this one. But you want to focus on what we are trying to prove is congruent. So again, we always start with our given statement. So our first statement is exactly what they told us. F-R-O-G. And our reason, how do we know that? Because it was given, because they told us up front. That's always going to be how our proofs are typically going to start. So let's think about what we're trying to prove, where we're trying to go, and what we probably already know, hopefully, if you know your parallelogram properties. If we know this is a parallelogram and I'm trying to prove that these two triangles are congruent to each other, again, I always think the best way, if it's possible, the best way to go about that is side, side, side. In my mind, that's kind of just what instantly comes to my mind. Are there other options? Absolutely. And the same thing with the one we just did on the first page. Another teacher could have shown you the same example and gone about it a different way. And that is totally fine. Okay, as long as is a legitimate reason to prove it, then you are good. I'm just showing you, I like to just show the easiest way, at least in my mind. So let's think about what we know. We know that FG would have to be congruent to OR, right? And how do we know that? Well, if it's truly a parallelogram, then our opposite sides would be congruent. So let's go ahead and note that. And for our reason, so our statement is FG is congruent to OR, and we know that because opposite signs, so we use the same statement on the other page. So let's think about the next thing that we could do. And again, there are a lot of different ways. Somebody might try to tackle, that those are vertical angles. That's totally acceptable. Whatever pops into your mind. I definitely, again, I'm going to go for side, side, side. So I notice I have diagonals here. And if this is truly, if FROG is truly a parallelogram, then I know that the diagonals bisect each other. And remember, when you bisect something, that means you cut it perfectly in half. We know that FO and GR bisect each other. So let's state that. So FO bisects GR. And how do we know that? Well, parallelogram diagonals bisect each other. If these two lines truly are dissecting each other, then let's break down what that actually means. So that means that FS would have to be congruent to OS, right? Notice I used a double tick mark instead of a single because the single was already taken down here. So let's state that. So FS is congruent to OS. And how do we know that? Well, if this if this line is being bisected by that line, then that's just a definition of a bisector. And some teachers are okay with you shorting like definition to def, right, with a period. So definition of a bisector. And then if we know FS is congruent to OS, well then we can also say that RS is congruent to GS, right? For the same reason, it's the definition of a bisector. So let's note that. And at this point, hopefully you now see that we've said, okay, this side is congruent to this side's congruent to that side, and that side's congruent to that side. So we can prove that triangle FSG is congruent to triangle OSR through side, 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 right? So let's note that. Let's look at one more example together. So notice this example is a little bit different. They've given us some angle congruency statements, which we'll look at in detail, but they're wanting me to actually prove that this ABCD, this shape, is a parallelogram. So this one's a little different from the other ones. The other ones just told us outright, hey, it's a parallelogram, prove these two triangles are congruent. But in this case, they're giving us just a little bit of info and saying, hey, actually work up to proving this is a parallelogram. So this one's a little bit of a different challenge. Let's start by just noting what the givens are and actually marking them on the picture and then going from there, seeing what makes sense. Our first statement that they tell us is angle BAC is congruent to angle DCA. And we know that has to be true because they gave it to us, right? It's a given. So let's go ahead and mark that on our picture. So we've got angle BAC. Now be careful you don't mark this whole side because that's not what they're saying, right? They're just saying BAC. So it's just this part right here. So that angle is congruent to angle DCA. So this angle right here. So those two angles are congruent. And then they also tell us in our second given statement that angle BCA is congruent to angle DAC. So let's, and we know that's true because again, it's a given. So let's actually mark that on our picture and see what that looks like. So it's saying angle BCA, remember it's always the middle letter, that's the actual like turning point, BCA. And this one is congruent, so I'm going to use a little double arc for that one. It is congruent to DAC, DAC. So it's congruent to this one right there. And then at this point, that's all they've told us up front. And they're saying, prove ABCD is in fact a parallelogram. So the first thing that I immediately notice is that we've got this middle kind of shared side here. So really this is two triangles. If I were to separate them out, like similar to the one we just did, this is actually two different sides. They're just overlaying each other. So anytime you have that, you can go ahead and mark it as congruent. So let's go ahead and note that on here, that we are saying line AC is congruent to, and I like to say AC is congruent to CA, just personal preference, right? They're the same line. So AC is congruent to CA, and we know that because of the reflexive property. And again, that reflexive property is something that's really commonly used with us saying, you know, something is equal to itself. Notice that we now have enough information to actually prove that these two triangles, so the top triangle and the bottom triangle, are actually congruent to each other. And we can do that because notice we have angle, side, angle. And angle, side, angle, or ASA, is a way to prove triangle congruency. So let's go ahead and state that. So we know that triangle ABC, so the top triangle, is congruent to triangle CDA. And the reason we know that's true is because of the angle, side, angle property. Okay, so you might be thinking, how does that help us prove that they're a parallelogram, right? That they create a parallelogram. Well, here's the thing. There's another property, and again, I touch on this in my intro to proofs video, but there's a property called, we just shorthand it by saying Cpctc, corresponding parts of congruent triangles are congruent. Okay, so basically what that's saying is that if I can prove that these two are triangles, you know, maybe I haven't said anything about these sides yet, right? This side BC and this side DA. But here's the thing. If they are corresponding parts of congruent triangles, then they are also congruent. So that's where that Cpctc comes in. So corresponding parts of congruent triangles are congruent. And it's not just these sides, right? I could say the same thing about these sides. So corresponding parts of congruent triangles are congruent. So once we know that two triangles are congruent, we can say a lot of things, okay? Pretty much any corresponding part on those triangles is congruent. So let's pick a side now and target it. So I immediately went for this BCDA, these two sides. So let's go ahead and do that. I can now say that side BC is congruent to side DA. And the reason I can say that is corresponding parts of congruent triangles are congruent. Cpctc. So after I went to those, I immediately went to those. So let's tackle that. Can I also say that line AB is congruent to line CD? Those are corresponding parts, right? And how can I say that? Well, again, we're using that Cpctc. Corresponding parts of congruent triangles are congruent. So remember, I can prove a parallelogram if I can prove that the two opposite sides are congruent. And I went over that in that parallelogram properties video, that if you can prove that these are congruent and these are congruent, then you've got a parallelogram. Okay, so we at this point have proved that. So we're ready for our prove statement. So ABCD is in fact a parallelogram. And how do we know that? in a parallelogram, and you could write this a ton of different ways, but I'm just going to write it that in a parallelogram, opposite sides are congruent. So that kind of wraps up our parallelogram proofs videos. We went through 3 different examples. If you have any questions, then definitely leave me one in the comments. This has been Miss Math Tutorials.